Alright, chemistry. It's a little bit of a review day, so no new notes today. Just want to show you some questions. A few of them are based on the page 12 notes that we finished the other day, so these guys. And some of them are based on the pages 6 through 10 notes. The reason I'm going kind of backwards, right, to pages 6 through 10 is because of the quiz that's happening on B-Day. So let's get into this. Let's just look at these questions. I'm not going to look at all of these questions. I'm going to cherry pick some of them. So the first one that I really want to look at is right here. It's number 3. I can blow this up just the tiniest bit. Okay, so here number 3. What statement describes the distribution of charge in an atom? So where is the charge in an atom, basically? Number 1, choice 1 says a positively charged nucleus. Okay, well, let's just like sit on that, right? The first part of each answer is about the nucleus. And if I look back, all of an atom's positive charge is concentrated in a very small core at the atom center known as the nucleus. They're protons, charge of +1 and a mass of 1. And all of an atom's mass is in the nucleus. It's all the protons and neutrons. And neutrons are neutral. They have a charge of 0. Okay. So, positively charged nucleus. Check. Right? It's either choice 1 or 2. Choice 3 and choice 4 are out of the question because they say that the nucleus is neutral. We know that's not true. The second half of the answer talks about electrons being either negatively charged or positively charged. Well, again, checking the notes, we just talked about this, and it is here. All of atoms negative charge can be found outside the nucleus. Electrons, negatively charged, surround the nucleus. So, positively charged nucleus surrounded by one or more negatively charged electrons. There it is. It's choice 1. Right? This is... Ooh, my phone. My goodness. Sorry about the interruption. This is about as wordy as it will get, right, for answers or for questions. A lot more times, the question will just look like something like number 7, something like number 8, at least for most topics. For most topics, they're pretty short questions. Experimental evidence indicates that the nucleus of an atom... Again, if right now I were to reference what's happening here, and I go back, and I look at this, all of an atom's mass is in the nucleus. There it is. The nucleus of an atom contains most of the mass of the atom. That's it. Right? It doesn't contain a small percentage. We said that it's positively charged, so choice 3 and 4 are just bad answers altogether. Right? All right. Number 8 is the next one I want to look at. What particle has no charge? We just looked at this. The particle that has no charge is the neutron. Neutrons are neutral. All right, so just keep that in mind. Be careful with that. Neutrons are neutral. All right. Now these questions, back and forth there, go all the way back to pages 6 through 10. A lot of them talk about, a lot of these ones in particular are like elements, compounds, mixtures, right? And I like to use these ones as the example because many times they show kind of what's always possible in that they might ask you directly about a definition, and they might ask you indirectly about a definition. So, let's break some of these down. Let me look at 58. Which of the following cannot be decomposed by chemical means? Decomposed is our science word for breaking things down, so which of the following cannot be broken down by chemical means? That's a definition. Something that cannot be broken down by chemical means is the very definition of an element. So which of the following is an element? Which of the following is found on the periodic table? That's choice 1. That's sodium. If I were to look at numbers, so this is a direct definition question, right? 60, like indirect definition. A compound differs from a mixture in that a compound always has a. Okay, we know compounds are different from mixtures, and the reason for that is that compounds have to be exact fixed ratios. You can't mess about with, well, maybe this much, or maybe... No, it's got to be exactly a certain amount. What that means is that it will always look the same. So if I have a compound, and I judge it one side to another side of the compound, it should look the same throughout. Keep that in mind. A homogeneous composition. We used homogeneous when we were talking about mixtures to describe mixtures that all look the same throughout. Chocolate milk, instant lemonade, salt water. Okay, so very possible. Let's keep it in the back of our heads. Number 2 is a maximum of 2 elements. So this is saying that compounds always max out at 2 elements. Glucose, C6H12O6. That's 3 elements. Definitely a compound. So, bad. Number 3, a minimum of 3 elements. Water is H2O. Definitely a compound. Only 2 elements. Bad. Heterogeneous composition. Compounds always have a heterogeneous composition, which is to say they always vary from part to part. So some water is H2O, and some water is H3O, and some water is HO2. No, that's not a thing. Water is H2O, plain and simple. So compounds always do have a homogeneous composition because compounds are pure substances. They always look the same throughout. And they'll act the same throughout. Right? Another thing the Regents likes to do is use always, or never, or all of the following except. Right? So we'll take a look at a few of these. Again, so if you were curious, right, these questions were, some of them were from page 5. These ones here are from page 19. These ones here are from page 20. So if I look at this, what is a characteristic of all mixtures? Okay, every mixture. So every mixture has to fit this definition. Every mixture is homogeneous. No, Chex Mix is not homogeneous. I can tell the difference in Chex Mix pieces, but it's still a mixture. All mixtures are heterogeneous. No, chocolate milk is a mixture. Chocolate milk looks the same throughout. Their compositions are in a definite ratio. Well, I could make my salad with a little bit of bacon, or I could make my salad with a lot of bacon. I could put Chex Mix with many pretzels or no pretzels. It's still salad. It's still Chex Mix. That's not true. Their compositions may vary. That is true. That's a definition for a mixture. It's something where the composition can vary. Speaking of mixtures, look at number 65. Which of these materials is a mixture? Water, we said, was H2O. Air. If I went outside and I analyzed that air, it might be different here than it is in, I like to use Denver, Colorado, Denver, or in Louisiana, New Orleans. Might look different, probably look very different from California, which I think is on fire again. The air is going to look different. Air is a mixture of many gases. Water is a compound. Methane is a greenhouse gas. It's a compound. And magnesium is an element. Right? If I were to look at page 67, which of the following materials is a pure substance? All right, so now we're asking which of the following is not a mixture. We just said air was a mixture. Off the table. Water. Water is a compound, and compounds are pure substances. Elements and compounds are both pure substances. All right, the next one I want to take a look at is number 69. What substance can be decomposed by a chemical change? So which substance can be decomposed by a chemical change? Which substance is a compound? Or which substance is not an element? If I were to look on the periodic table, I could find aluminum, it is an element, and magnesium, and manganese. Ammonia is a compound, commonly found in cleaning supplies. You would probably recognize the smell of ammonia. Those are all very typical multiple choice questions, things that you might see, things that you might run into. There are also short answer questions. When I say short answer, I mean short answer. So you can keep these brief. 1, 2, if you can answer a word in 4 or 5 words, great, do it. You do not need to use a complete sentence. Please don't waste your time writing them, and it saves me time reading them. Right? Is pepperoni pizza homogeneous or heterogeneous? Can you tell the parts of pepperoni pizza apart from each other? Can you tell the pepperoni from the cheese, from the crusts? And yes, I can. It's a mixture. It's a heterogeneous mixture. It's heterogeneous because I can see the different parts. If I look at these 4 containers, this one does say use complete sentences. In the very rare case that it says to use complete sentences, please do so, but otherwise, don't bother. Right? This is a very rare case. I would classify C as an element because it has only one thing attached to itself. It's not two or more different elements chemically combined. I would say that this is an element. I would say that B is a compound. It's one big dot, three small dots. A and D, I would say, are both mixtures of elements, because they have the two black dot pair, and compounds. A has only one compound, one big dot, two small dots. D has two compounds, one big dot, two small dots, one big dot, three small dots. That's how I would classify them. Finally, number 76, are the contents of container D, right here, homogeneous or heterogeneous? I would say that this is heterogeneous, because there are very clearly different pieces in this mixture. The contents here are heterogeneous. The contents here are homogeneous in C, and in B, they're homogeneous. Right? The element and the compound are homogeneous because they are the same throughout. All right. Again, the reason I went through these questions is as a review. They're a review for the quiz on B-Day. All right. If you have more questions, if you want more practice, send me an email. I'll be happy to find some more questions, probably from this section that you can do, and I can send you answers. All right. Now, the explanations for each of these are also in an assignment. I put assignment in quotation marks because you do not need to submit anything. I am purely putting up literally the questions that I went over here and the answers in a document that's attached to that, right? So I wanted you to have these pictures just in case you don't have your book handy. I wanted you to have those explanations in case you don't want to watch this video. You can read them, right? Now, your only work to do before B-Day is to make sure that you are prepared for this quiz, okay? Send me emails if you have questions. Otherwise, I will see you on B-Day. Take care, kids.